Ladies and gentlemen, today we get to talk about, we've talked about to this point, multiplying, adding, subtracting polynomials. Now we have to talk about how we're going to multiply special cases of polynomials, specifically binomials. So what if we have this binomial, x plus 1 squared? All right, so we know from previous lessons that all we're going to do is rewrite it as x plus 1 times x plus 1. All right, and then we can do our double distributing, which we'll say x times x is x squared, x times 1 is 1x, 1 times x is 1x, and then 1 times 1 is 1 squared, or 1. All right, then we combine like terms here and get x squared plus 2x plus 1. And that would be our final answer. Okay, pretty straightforward. We just did this in our previous lesson. But what if we have x plus 1 to the third power? Well, essentially, we would rewrite it as x plus 1 times x plus 1 times x plus 1. Now, a few years ago, I had a student that chose to do it this way. I don't recommend doing it this way because, just like I was saying before with double distributing, you might miss a term or something like that. So our wonderful previous mathematicians, specifically a man named Pascal, came up with a nice theorem we call the Binomial Theorem. And in order to accomplish this Binomial Theorem, what he did was he developed a relationship between various powers of 1, well, various powers. So the first thing you do is you start off with 1. That's we always start with that. So we're going to call this row 0, okay, because it's our first row. You would think it would be row 1, but I'll show you why we use row 1, why we will use row 0, and then we come back to the other rows. Now row 1 is actually going to be 1 and another 1. Now you see how I spaced them out? There's a reason why I'm spacing them out, because it's supposed to form a shape. And at the end of the shape, I'll show you, well, I'll call it what is, I'll give you the name of it and tell you why we call it that. Or explain if you haven't figured it out. So what you want to do is, in order to find, and so to make this shape, your first number and your last number will always be 1. The ones in the middle are always determined by the two numbers above them. All right, so you have 1 here and 1 here. So 1 plus 1 is going to give us 2. Okay, and that gives rise to row 2. Okay, so remember our rule. The first number and the last number have to be 1. And then we use the top numbers to come up with the middle numbers. So 1 plus 2 is 3. And then 2 plus 1 is 3. This gives us row 3. Again, next row, we're going to put 1 here, 1 here. So we're going to say 1 plus 3 is 4. 3 plus 3 is 6. And then 3 plus 1, again, is 4. And that's going to be row 4. All right? Again, 1 and 1. So then 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, and then 4 plus 1 is 5. So again, row 5. And then the last one we're going to do is row 6, in 1 and 1. So 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, and then 5 plus 1 is 6. And therefore, we have row 6. So I apologize for my drawing, but essentially, this should look like a triangle or a pyramid. And so this structure is called Pascal's triangle. All right? So Pascal's triangle allows us to take x to the third or x to the fourth power, and without having to do all that double distributing or box method, and expand that binomial into its true form. All right? So what we're going to do is, if you ever forget it, guys, always look for the numbers in your row. The second number will always tell you what row you're on. Row 6 has a 6. Row 5 has a 5. Row 4 has a 4. Row 3 has a 3. Row 2 has a 2. Row 1 has a 1, because remember I told you the second number. And then if you notice there's no number up here, that's why we have row 0. All right? So let's go ahead and work out a problem. I'm going to refer back to this pyramid in a minute. So let's work out a problem. Let's go back with that problem we originally had, x plus 1 to the third power. All right, so we look at our exponent, and our exponent is a 3. Sorry. Okay. It's a 3. So that means we go back to our triangle, and we look for 3, row 3. So this is the one we want. We want this row here. What we're going to do is we're going to take, remember the numbers 1, 3, 3, and 1. So you're going to come over here, and you're going to write a 1, a 3, and then a 1. And you see how I spaced it out? There's a reason why we spaced it out, and you'll see in a few minutes why we need to space it out. So the first step is, once we find out what row, we write the coefficients, or the big numbers that will be part of our expression. We take our first term, which for our purposes will always be an x or a y. All right? So we have x, so we write an x by each of our numbers. I usually put them in parentheses, guys, but you don't have to. But this is just the way I keep my stuff ordered and organized. And then you start with the exponent you began with, which was 3, and you count down to 0. So that means our first expression is going to be 3. Second expression is going to be 2, 1, and then 0. All right? So that takes care of our first term, okay? Our second term, we're going to do again, same thing. We're going to put parentheses 1, parentheses 1, parentheses 1, and then parentheses 1. And then instead of counting down, we're going to count up, starting from 0 up to that exponent, which we said is 3. So it's going to be 0, 1, 2, and 3. All right? So now that we have written out our new coefficients, or our big coefficients, 1, 3, 3, 1, we write the first term, and we put an exponent by it, and we always start from the biggest exponent, which is 3, and count down to 0. Okay? Now, if it's 4, 5, 6, whatever number it is, you always start with that number and count down, and that's the first term. The second term you always count up when you do exponents. So you start from 0 and you should end on 3. So your first term should always start. The first term should always start on 3. The second term should always end on your highest exponent. Okay. So next thing you want to do is now let's start simplifying. Well, with our variables, we can just rewrite it as 1 parentheses x to the third. Sorry, I was just telling you not to do that. And get rid of the parentheses. You don't have to keep the parentheses, but I just do that just for organizational purposes. All right? So then 1 to the 0, any to the 0 power is 1, guys. Okay? Any to the 0 power is 1. All right? The next we're going to write is 3 and then x to the second. And then 1 to the 1 power, any to the 1 power is itself. So we're just going to have a 1 here. All right? Do the same thing for the third expression. A third term, so we're going to write 3x to the 1, because that was our 1, and then 1 squared is 1 times 1, which is 1. And then lastly, we have 1, and then remember I told you any to the 0 power, letter or number, will always be 1, and then 1 to the third power is 1 times 1 times 1, which is also 1. All right? So we're almost done. The last thing we need to do is multiply our numbers times each other. So we're going to say 1 times 1 is 1. So that's going to be x to the third. Then we have 3 times 1 is 3. So we're going to say plus 3x to the second. And the reason why I said plus, guys, I want you to remember, if there's not a minus sign in front of your term, meaning that it's not a negative term, you put a plus sign. Okay? 3 times 1 again is 3. And x to the 1, we just write as x to the 1. All right, and then lastly, 1 times 1 times 1 is 1, okay? And so now we have successfully expanded x plus 1 to the third power, and that's our final answer. Okay? So it's an involved process, guys, but you can get through it. I promise you, you will get through it. All right? So let's go with this time x plus 2 to the fourth power. We're just going to do one more example. All right? I'm going to do one more example, then an enrichment problem, guys, just so that, because normally if we were in class, I was doing this live with you, I would do an extra problem, but we're going to go ahead and do that. All right? So x to the fourth. I'm sorry about my 4 looking almost illegible 4, okay? So we go back to our Pascal's triangle, and we look for row 4. Row 4, this time, is this one. So that means we want 1, 4, 6, 4, and 1. So come over here, again, 1, 4, 6, 4, and 1. All right, so you always write out those coefficients. Our first term, again, just like before, you're going to write x, parentheses, by each of your numbers. And then remember what I said, we always count down. So in this case, our highest exponent is 4. So we're going to say 4, 3, 2, 1, and then 0. All right? Then we come back to our second term, which in this case is going to be 2. And this time, instead of counting down, we count up. So we're going to say 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and 2 to the 4th. Okay? So now, just like before, now that we've done all our terms, we're going to simplify. So we bring down 1 and then x to the 4th. Remember, 2 to the 0, guys, is always 1. Okay? Then you come down here, do the same thing. 4 times x to the 3rd. 2 to the 1 is itself, so it's going to be 2. Come down here, 6x to the 2nd. Remember, 2 times 2 is 4, so that becomes 4. Now, what I didn't tell you guys in the first example, because all of our numbers were 1s, so it was easy. If you ever forget your powers of whatever exponent you do, multiply the first term, the previous term, by the number in parentheses. So 2 times 2 is 4. So 2 times 2 is 4. And do it here again. This 2 times this 2, when we simplify, is going to be, I'm sorry, this 2 times this 4, sorry, apologize for that. Times this 4 is going to be 8. Or if you just know 2 to the 3rd is 8, that's fine. All right, and then lastly, we have 1 and then times 1, because remember, anything to the 0 power is 1, and then 2 to the 4th, that's going to be 16. All right, so our last step is to multiply all our numbers. So 1 times 1 again is 1, so x to the 4th. 4 times 2 is positive 8, because we have positive 4 times positive 2. 6 times 4 is positive 24, x to the 2nd. 4 times 8 is positive 32x to the 1. And then 1 times 16 is positive 16. All right? So that's our final answer. So again, guys, once you get the hang of this, it actually goes pretty quickly. So don't freak out. That's why I gave you a good number of practice problems on Google Classroom and Schoology. So guys, please practice this, because on the test, you do have 2 problems like this that you're going to have to expand, I'm sorry. All right, so let's flip over to another page, and we'll do, this time we're going to do x plus 2, and never mind, not plus, we're going to do minus, because we've done plus all this time, so we got to do some minus problems. So we're going to say x minus 2 to the 5th power. So we go back to our Pascal's triangle and get our coefficients. This time, since the 5th power is going to be row 5, so that's 1, 5, 10, 10, 5, and 1. So come over here again, and write 1, 5, 10, 10, 5, and 1. All right, we go back to our first term, which is x. So again, we start with the highest exponent, x to the 5th, then x to the 4th, x to the 3rd, x to the 2nd, x to the 1, and x to the 5th. All right, then the next thing we do is we take our second term. Now this time it's a negative number, so you got to put it in parentheses and put -2, and that's what's going to go behind our variable. Sorry guys, when I'm on the board I have a little more space, so I'll try to write a little smaller. All right, so then this is going to be 0, 1, 2, 3, 4, and then 5. And I'm sorry guys, I just now noticed I don't know why I put 5 here. I kept saying, I said, why does that look 5? So it's actually supposed to be to the 0 power. Okay. All right, so again, we need to simplify. I apologize for the messiness of it, but it'll be 1 times x to the 5th. Remember, -2 to the 0 power, ending the 0 power is 1. Okay, then we're on the next one, 5x to the 4th, and then ending to the 1 power is itself, so it's going to be -2. All right, then come down here, it's 10x to the 3rd, -2 to the 2nd power is going to be +4. Then over here, it's going to be 10x to the 2nd, and -2 to the 8 to the 2nd power. -2 to the 3rd power, I'll get my tongue tied here, sorry guys, is -8. 5 times x to the 1, this is going to be +16. And then lastly, 1 times 1 times -32. Okay? So now, again, just like before, we're going to multiply our numbers and simplify. 1 times 1, again, is +1 times +1, that's going to be x to the 5th. All right? Then next one we got is 5 times -2. Well, 5 times -2 is -10. Again, x to the 4th. 10 times 4, this is both positive, it's going to be +40x to the 3rd. 10 times -8 becomes -80 x to the 2nd. 5 times 16 is +80 because it was both positives. And then 1 times -32 is going to be -32. All right? And so that's our final answer. Now, if you notice, guys, because we had a negative binomial, you had an alternating pattern of signs. You had negative, positive, negative, positive, negative. On the test, guys, I'll go ahead and give you a couple of test questions. On the test, you'll be given this problem, and your answer choices will be this answer. You could also see x to the 5th plus 10x to the 4th plus 40x to the 3rd plus 80x to the 2nd. Sorry, my handwriting is getting low. I'm trying to write a little quickly here. Plus 80x plus 32. Now, if you remember what I said, guys, if you have a binomial that has a negative term in it, you're not going to have all positive answers. Okay, all your terms not going to be positive. You're going to have an alternating pattern. Okay, so you can go ahead and eliminate that answer choice, and vice versa. You're not going to have all negative. Just because you have a negative binomial, you're not going to have all negative numbers. Okay, that's not right. Okay, that's not right. So you can't have all positive and you can't have all negative. Okay, and that's usually what trips most people up is they don't want to work out the problem, so they're like, oh well, I got -2, so that means all my answers are going to be negative. No. So try not to do that, guys. For the sake of time, guys, I do want to do one more. It's not going to be on the test. It's not going to be on the test, so I do want to do one more so you can see this if you're taking the ACT or SAT or even the ASVAB. What if, well, we'll do two more, sorry. The first one we're going to do is, what if you have it in a different order? I told you for our purposes, the x or variable always comes first. What if we have 1, and I'll take it easy on you, plus x, and let's say this is to the 4th power. All right, it's the same concept. Remember, row 4, our coefficients were 1, 4, 6, 4, and 1. All right, so you're going to do the same thing. And now this time, instead of doing x first, we're going to do 1 first, because that's our first term. So it's going to be 1 to the 4th, 1 to the 3rd, 1 to the 2nd, 1 to the 1, and then 1 to the 0. All right? Then the last one we're going to do is x. So this is, instead of it being x to the 4th, like we did before, it's going to be x to the 0, because it's our second term. X to the 1, x to the 2, x to the 3, and x to the 4. All right? So now we want to simplify. So x to the 0 is 1, so we're going to be left with 1 times 1 to the 4th times 1. Then next we're going to have is 4 times 1 to the 3rd times x. Then we're going to have 6 times 1 to the 2nd times x to the 2nd. And then here, 4, 1 to the 1 times x to the 3rd. And then lastly, 1 times 1 times x to the 4th. All right, so just like before, guys, we're going to multiply our two numbers. This time they're in the front, so we don't have to do a little semicircle or whatever. 1 times 1 to the 4th is going to be just 1. And then 1 times 4 is 4x. And then 1 times 1, again, is 6x to the 2nd. 4 times 1, again, is 4. And this time x to the 3rd. And then lastly, 1 times 1 is x to the 4th. All right? So it's in a different order, but it's the same concept, guys. So I wanted to at least let you see how that's done. All right? So the last problem we're going to do is, what if we have 2y minus 2? And let's say this is going to be, we'll take an easy one. We'll say to the 3rd power. All right? So before, all of our variables did not have a coefficient greater than 1. So what do we do in that case? It's the same concept, guys. We're still keeping the same thing. We're saying that entire term of 2y is going to be elevated to the 3rd power when we expand. So remember our coefficients for row 3, because remember that's our exponent, row 3. 1, 3, 3, and 1. So again, our first term is 2y. So we can say 2y to the 3rd, 2y to the 2nd, 2y to the 1st, and then 2y to the 0. All right? Now our second term is going to be negative 2 to the 0, negative 2 to the 1, negative 2 to the 2, and negative 2 to the 3rd. All right? So here, when we're simplifying, remember we'd always put the variable with the exponent. We got to elevate both of these numbers. So 2 to the 3rd power is going to be 8, and that's going to be y to the 3rd. Okay? And then negative 2 to the 0 power is 1. Okay? This one here, we're going to do the same thing. 2 to the 2nd power is 4, and it's going to be y to the 2nd times negative 2. All right? 2 to the 1 power, all we're going to do is rewrite it as 2y. And negative 2 to the 2nd power is 4. And then lastly, we have 2 to the y to the 0 power is 1. And then negative 2 to the 3rd power is negative 8. Okay? So now all we need to do is multiply all our numbers. This time, instead of having 2 numbers, we got 3 numbers because we got this coefficient here. So we got 1 times 8 times 1. So 1 times 8 times 1 is 8. Then bring down the y to the 3rd. Then we have 3 times 4 times negative 2, which is going to be negative 24 y to the 2nd. And then 3 times 2 times positive 4 gives us positive 24 y. And then lastly, 1 times negative 8 is negative 8. And that's our final answer. Okay? So again, you will not have a problem like this one. So this is not on test. and this is also not on test. I did these problems, guys, as sample problems, so that way if you're taking the ACT, SAT, or SAT, ACT, or ASVAB, if you get problems like this on either of those, any of those tests, you know how to handle them. But for our purposes, guys, the questions you're going to see on the test are like this one, and like this one, and like this one. Okay? So that's all you're going to have to do. So that's about it for today. I probably have talked your ears off, and I know they say you shouldn't really talk more than 20 minutes, and so that usually keeps people's attention. So Ms. Lambert will, after showing you this video, she's going to open up for questions. I do have another video that another teacher made up. You can also look up on YouTube if you want to look it up. And the topic you'll look under is Binomial Theorem. So hopefully between the one I've uploaded to Google Classroom and this one, you'll get your information. But because I can't be there with you in person, unfortunately, I'm having to do this video. But again, guys, please feel free to watch this video or the other videos. Or if you have questions, Ms. Lambert, please ask her at this time. Well, I hate I'm not there with you guys. I'm thinking about you. I'm in a meeting, and so unfortunately I couldn't get out of the meeting. So, which I signed up for a class, and this is the day I chose to meet. I wish you well. So again, guys, just to finish up some last minute housekeeping. Guys, don't forget to do your Google Classroom stuff and Schoology. Unit 1 is due this Friday at 11:59 p.m. Unit 2 is due next Friday at 11:59 p.m. Unless you've talked to me or Ms. Lambert, you should be turning your work in by that point. Guys, I am starting to put grades in. Some of you have already noticed I put some grades in. I did not put missing grades in yet, but I'm going to start putting them in this weekend. So some of you guys need to hurry up and turn in some work, guys, because I don't want your grade, because we haven't had a lot of grades. So a 0 here and there is going to do some damage to your grades. So again, guys, please work on your the practice problems after this lesson. This is a part of your Google Classroom as well as your Schoology lesson. Tomorrow's lesson will be synthetic division. I thought about recording 2 videos, but we're just going to do 1 and then call it a day. And then, like I said, just watch the video. I think I might record a second video along with it, but again, we'll go from there. Well, I again miss you guys, ladies and gentlemen, and I can't wait to see you again, either through Google Meets or Classroom. Hopefully Classroom, because this was technically our last Google Meet for the week. Hopefully we will be back in class, back face-to-face next week. But if not, I appreciate seeing you guys on Google Classroom and the Google Meets. Well, I'll talk to you in the next one. Bye.